You are entering the Nillyverse with your hosts Gustavo Candia and Rodney Perry. This episode has been brought to you by the Society of Namecoin. No. Hello and
Hi.
morning.
Morning, Gustavo. How you doing?
Morning. I'm going to start to introduce the topic. I want to remind our listeners or viewers that we've reached the final section of our book where we explore what aspects of science are ripe to be reinterpreted teleologically. And by that I mean with clear distinction between the terms nothing and nothingness. Today's subsection, entitled The Instability of Nothingness, focuses on how ubiquitous and wildly fecund the concept of nothingness in particular is in contemporary scientific literature.
Right.
So just as we've done throughout the series, we'll mainly draw here from Krauss's A Universe from Nothing to help illustrate our point. So in trying to define nothing, Krauss says that if you would have asked Plato if his nothing would be roughly equivalent to empty space, Plato would have agreed with that statement. But it's totally unfair to ask Plato what nothing is, knowing what we know now, imagining that he wouldn't know such things were he alive today. The definitions of mass, energy, space, time have all wildly changed since Plato's time. Right? The ancients believed in the atom being indivisible, for instance. Were they to be alive today, they'd still probably hold to that belief and would resolve the contradiction with nature, or what we observe nature to be like, by saying that what science was able to split were obviously not atoms, but something else, something in between. The definition of atom, like that of nothing for Krauss, evolved in such a way so as to be able to observe it and study it in an objective way. Atom, for the ancients, was a metaphysical concept, never to be observed by something that must exist. Similarly, the problem with making nothing something is that nothing should refer to non-being and not something imbued with even the potential of producing something like virtual particles in a way where we can attribute a cause to nothing. So as we pointed out many times, pops, or popularizers of science, oftentimes unfairly cite ancient and Renaissance thinkers. They'll use these thinkers' words sometimes to give their own ideas legitimacy, or if they want to contrast old thinking with new thinking, draw from otherwise venerable texts, right, to showcase how wrong their objective truth, the objective truth was known back then. Seldom do they consider that the truth that these thinkers contemplated wasn't exactly at all times focused around the objective facts as the modern scientist concerns himself professionally. Believe it or not, Krauss says the following in his book: nature is cleverer than philosophers or theologians. But how can nature be intelligent? Intelligence, the intelligence behind intelligent design? Actually, Krauss also curiously says at one point that he has cosmic humility. Though I don't want to take him out of context, I'd like to know, what is it that he could be humbled by? What is he humbled by when he says has cosmic humility? Truth be told, in the last chapter of A Universe from Nothing, it actually gave me a newfound respect for Krauss's position. He accepts, if you read it carefully, right, he accepts the relativeness of his truth. If it is, as it appears to be, that quantum mechanics, relativity, string theory, and the weak anthropic principle taken together suggest that the possibility of an infinite number of universes, each potentially with their own unique laws particular to each universe, and by potential, Krauss really means highly probable, according to Krauss, when it comes to the multiverse, then whatever truth we can muster here on Earth, right, would likely not be true on Earth Prime, this clone of our Earth, with everything that we know about Earth, with maybe slightly different constants of nature. It would be another set of truths, even though it seems to be the exact same thing. So my question is this: if objectivity cannot lead to communication between organisms from different universes, shouldn't we be looking instead as scientists, or maybe more, metaphysicians, theologians, philosophers, right? Shouldn't we be looking for a language and laws that do? Science, I think, consistently affirms the ontology of theological ideas. The Big Bang, Higgs field, virtual particles, quantum uncertainty, yet deny their explanatory value. So once you have a scientific explanation, we can say that it might be better than the theological at describing what the physical world is like, but the spirit of the experience which led to the writing of the theological texts and those actual words they eventually settled on, this should not be made redundant just because we have a better explanation of the facts. There's something very real there, and the scientific explanation doesn't account for it. I guess in closing, I want to draw from mathematician Robert Kaplan from his book, The Nothing That Is, A Natural History of Zero. He sums up a chapter in his book thusly. He says, and regarding nothing, the nothing that is, there is no zero, no nothing, no void in the manifest world. No nothing in terms of space, time, matter, or energy. When thought through science, nothing always turns out to be something.
Always turns out to be something.
So essentially what Kaplan is saying is that nothing eludes scientific investigation. And the way I like to think around, remember we can't think about, the way I like to think around this is nothing is the pull towards yet unthought ideas.
Good.
So that's, I guess, a little introduction on the instability of nothing.
Well, I have some things there. Well, it's just interesting. I mean, Krauss, we did a very long point-for-point analysis of Krauss, because I always made this little joke here somewhere that Krauss seems to carry a little dagger in his pocket.
Sure.
Whenever
and a dagger or venom.
Yeah, it's got venom in the point.
Yeah.
Whenever he has, whenever a theologian or a philosopher comes now around him, he likes to poke him,
Sure.
So Krauss is a very interesting fellow, and very smart, and kind of infuriating in many ways, the way he goes about his stuff.
Confusing too. His text is very
unbelievably confusing. Yes, we noted that he uses the word nothing in at least 4 different ways in his book and so forth. But he's quite a person, and he's been profusely awarded throughout his career, and a very interesting man. One of the things that I talked about before is that there is this tendency, and Krauss does it all the time, there's this tendency to use religious philosophical language to draw people into the book, and then deny that they're using religious language. And as you've just gone through his universe from nothing, that is a classic example of hearkening to philosophical past, to the history of questions about meaning and so forth. And then by the time you get to the end of the book, he actually undercuts almost every word in the title. But anyway, very interesting guy. And this notion that nothing is what draws us.
Nothing is the pull towards yet unthought ideas.
That's a great way of putting it. We've never done that before. It's what we call the leaning into, leaning over the cliff edge and so forth. It's what draws us into yet unthought ideas. Let me just show a parallel in a religious philosophical tradition to that language that the popularizers of science have come up with. What I'm trying to do here is show that it is, as we've said repeatedly, it is the pattern of knowing that reveals the nature of reality. And in this sort of seminal idea that nothingness is unstable, we find an exact parallel in a Sanskrit tradition called Sankhya. So let me just review a little bit, so that we can do it. I'll just quote a couple of the scientists about the instability of nothing. We need to be very specific in our analysis, had to show that, in fact, the way we use the word nothingness is the way that popularizers of science use the word nothing. We have a much more sophisticated vocabulary of nothing and nothingness. So here's a couple quotes. Frank Wilczek, who we've talked about quite a lot, he says, the answer to the ancient question, why is there something rather than nothingness, would be that nothingness is unstable. Nothingness itself is unstable. And then K.C. Cole, a science writer, says, potential, as it turns out, is one of the most impressive properties of nothingness. And what they're saying there, and this is very interesting, is that it is the very nature of nothingness to be unstable and to bring forth things. Let's look at that parallel in Sankhya. And remember, the Sankhya philosophy, one of the classics of Hinduism, we talked about it a lot in section 3. I called them the masters of observation. They meditated with their eyes open. They were really analyzing the world around them as they could see the manifest world. And when you look at Sankhya, having our understanding that we do now of popularizers of science, we see that the Sankhyans are actually quite prescient in what they said about how the world comes to be. So, according to Sankhya, the world has this name, Prakriti. Prakriti means to go forth. It has a sense of action about it. And Prakriti is often thought to be a female, so they referred to as she. She's made up of these qualities, these characteristics of manifestation called gunas. There's actually a word that would be similar to our English language, attribute. There are 3 of them. There's very light, there's very heavy, and there's motion. And those 3 things is what's said to make up the manifest world. So what's important for us in looking at this parallel description is that when Prakriti goes into the unmanifest state, that means that the world, the physical world, isn't manifest, but yet is still there in the quality of all those gunas. When she goes into the manifest state, the gunas are still there. It doesn't disappear. Those qualities of manifestation are still there. So if we take popularizers of science language and insert the vocabulary of Prakriti, this is what it sounds like. Prakriti in her unmanifest state is inherently comprised of unstable productive energies, and it causes the world to manifest out of itself. The world goes forth as something manifest from a pre-existent nothingness. That sounds exactly like Krauss. It sounds exactly like Wilczek. The unmanifest world, the nothingness, is inherently unstable, and it brings forth the world. This was a language that came to be in the 2nd and 3rd and the 4th century in India, and it is quite parallel to the language of the pops that we have today. Again, instead of talking about the quantum vacuum bringing forth the world, we talk about the unmanifest Prakriti bringing forth the world. And so we see that the Sankhyans are actually quite quantum mechanics, and it's a long time ago. So let me do just a couple more things about this parallelism, because again, I think it really justifies our notion of the pattern of knowledge. So one of the things that's interesting about Sankhya is that this parallel language of the instability of nothingness came, but that worldview, that metaphysic, that cosmology of Sankhya was fully allowing of nothing. Nothing was also an integral aspect of that universe. What I think one of the things that we're noting to the popularizers of science is that when you start to validate the parallels of these philosophical positions, and you see that nothing is a full part of that worldview, it might behoove the popularizers of science to begin to allow that nothing is an aspect of the universe that they should be looking at. They would do well to heed some of the Sankhya masters. So just a couple suggestions for the popularizers. The general notion that has been taken up by popularizers is that nothing is not to be found within the world of the material. So another suggestion that we are bringing forth in our book for the popularizers of science is that we remember we talked about the rarefying principle a lot in our book, and in that we talked about the rarefication of the world, the less matter in the world that was found, the more understanding was brought out by that rarefied state. And what we also noted is that when we talked about the rarefying principle, is that it has its parallel in the rarefication of the self. And it is through the rarefication of the self and the rarefication of the natural world that you get a greater understanding of the nature of the world. So one of our things that we need to recommend to the popularizers is that this fervent, almost rabid search for the nature of nothing within the manifest world needs to be paralleled with an investigation into the nature of the researcher themselves.
Mhm.
So it's the researcher as well as the manifest world, the so-called scientific world that will lead to a greater understanding of the nature of reality. It's not really such an outlandish thing. I mean, in a certain sense, if we were just coming to this one podcast today and saying, how can you ask the researchers to be self-reflective? But that's not such an outlandish request, or not such an outlandish suggestion, as we've seen in a lot of the things that we've looked at earlier in the book. That when the popularizers gave up mathematics and started doing this popular form of literature, they became storytellers. And when they became storytellers, they became inherently part of the story they were telling. They were bringing themselves. They started the I came into what was formerly said to be an objective science. So the bringing of the I is already there, done by the popularizers. So we're not suggesting this out of nowhere, but we've seen that tendency before. We also looked at the uncertainty principle and the anthropic principle, which are scientific principles, which are, again, bringing the nature of the observer, bringing the nature of the consciousness into the world that the scientists are looking at. So the scientist is already becoming an aspect of the research, and we're saying that a greater kind of like going further with that understanding will behoove them and make them better scientists. It could be, I mean, we talked a lot about disciplines that the traditions of religion have in the East and in the West of looking at oneself. Those are various forms of self-forgetting, prayer, meditation, and so forth, interacting with the sensei in ways that reveal the nature of the self and so forth. And so we've seen that one of the ways that we typified religion is that they are the masters of disciplining themselves for understanding nothing. And it would be a little bit, I think it would be a little far-fetched to ask our popularizers of science to become renunciates or to become navel-gazers or yogis or any of the other words that we see in the literature. We aren't asking scientists to take on that sort of reflective discipline, but there is something that we can recommend for the popularizers. So all the evidence that we've put out in these 300 pages of our book and so forth, and that evidence garnered from religion, science, and philosophy, we determined that nothing is a fact of reality, and that what we can do is encourage popularizers of science to believe in nothing. We can encourage popularizers of science to have faith in nothing. And as we've seen before, earlier on, faith serves as a heuristic. Faith in an understanding that's out there beyond the realm of conscious thinking. Faith in that allows one to lean into, as we say, as you said, this is again, now we're finally coming back to what you had said. This thinking around nothing allows you to come to new understandings that you've never had before. Faith in nothing allows a greater understanding of nothing and then an improvement of your science. So again, this is not some sort of outlandish or idealistic recommendation coming from some pulpit to the scientists. Because as we've said earlier, and we've looked at this very closely, the pops already take advantage of the heuristic nature of faith. Right. And we showed that very clearly, that, for instance, there is a belief on the part of pops that the universe has a single essence. That's a belief. There's faith in that. And that allows them to look deeper into the notion of a single essence. There's also a faith that the universe has a unified nature. That is a single realm of law that can be explained in one theory. That is a belief, in fact, not a objective empirical notion. Of course. And also we've seen that popularizers of science have faith in beauty. Beauty, they believe, will guide them to a better understanding of the world at hand. So asking popularizers of science to have a faith in nothing. It's nothing. It's something that is already occurring for the popularizers of science, and we're pointing out how, in fact, that can become effective, better scientists.
Right. These concepts like of beauty. Beauty is nothing with respect to everything that is real, scientifically speaking. Not a real concept for science. It's not something that's tangible or something quantifiable, even. You have a sense of it, yeah, but it's beyond science. So, although this is not how we define it, but at the very least, the scientist could grasp at this definition of nothing, and that is something that's beyond scientific reach. Beauty is beyond scientific reach. You're not going to describe it, going to fully appreciate the feeling that you get, when you see something that's aesthetically pleasing, besides actually experiencing it. So if you can appreciate that, right, then you can start to see where we're going with nothing, right? The belief in nothing, that over the cliff edge, taking a step beyond what you're comfortable with, right? What's scientifically defined, and accepting a beyond.
So I'll just stop with this one sentence there, one statement, and it's just a little bit of a pride in the work that you and I have done together.
Mm-hmm.
So I just wanted to refer back to Heisenberg's book, Physics and Philosophy. And along with his contemporary physicists, Bohr and Oppenheimer and so forth. And they speak of the transformative effect that quantum theory has had on the philosophy of the time, as well as the kind of like the basic notions that common people have about the world. That quantum mechanics has had an amazing paradigm shifting sort of effect on the way we see the world. And it's my sense, and so I think it's our sense, that an appreciation of nihilology will have the same sort of effect on the way we see the world. That a kind of deep and subtle understanding of what we've been talking about with nothing and nothingness will actually change the way that scientists see the world, will actually transform, evolve would be the best word, evolve the investigations of popularizers of science and make them better scientists.
Absolutely.
So that's just an affirmation.
I agree. And just to bring up a scientific instantiation of this nothingness being something, right? We've talked about sort of virtual particles, the Big Bang, where does the universe come from? And we'll see that in the Hop on Pop session today. But remember the idea of destructive interference, right? We have one beam of light coming from from the left, another beam of light coming from the right. They're perfectly symmetrical, right? But one is the flip of the other, the reflection about the y-axis. And as they meet, so they're two photons of light. As they meet, they destructively interfere, means that for a moment, as they cross paths, the resultant wave function is nothing, right? Or nothingness. And it's dark. And if you were to measure, there wouldn't be anything there that you could measure. But we know that if we just give it a little bit of time, then the light would emerge to the left and to the right as they pass through the center. Now the waveform sort of just passes right through and then continues along its way. But for a moment, it was nothing. So maybe what we're observing at any given moment, right, is that destructive interference. And the universe is teeming with real particles that we just can't measure because it's not, our scientific instruments are engineered to measure at a certain time and a certain manner in space-time. And we just have to wait a little bit longer, or we have to tweak where it is that we're looking, and then we would see the waveform, right? But that's one example of like how you have it there. Well, like you've observed this all like yourselves. This idea of nothingness is all around you, the scientific textbooks and your knowledge. So it shouldn't be a far stretch to accept nothingness. All we're asking is to reserve another concept for those things beyond the scientific purview, just so as not to confuse two things, to confuse that everything that science, those subjects of science, right, from that which it cannot speak to.
Very good. A little chaotic help there.
We have a clip today from Sean Carroll, who is a popularizer of science that we do feature that we do reference in our book. Mm-hmm. And here he's talking about how he comes to terms with the question of like why there is something rather than nothing. A very reasonable position, might I add. In fact, if we were to be charitable with Krauss and reading Krauss again, if we were to revisit Krauss, I would grant him that this is what Krauss wanted to say, essentially.
That's great.
It didn't quite come out. It didn't come out.
Great. Didn't quite make it.
Didn't quite make it, but this is what he meant. Okay, so let's listen here.
Yeah, well, I think that there's a confusion between different versions of this question, because like many questions you can sort of casually ask on the street, a more careful, rigorous scientific examination gives you different possible meanings to the terms. So if what you meant by that question was, how could you start in empty space or a quantum vacuum and then evolve according to the laws of physics into a universe like we see, we have plausible answers to that question. There are physical theories that do that. We don't know whether any of them is right. We don't have the final answer to those questions, but it doesn't seem hard. There's no insuperable obstacle. Many people have in mind the deeper question of, but why is there quantum mechanics? Why are there laws of physics rather than no laws of physics, no thing at all? And that, I think, is a different question. It's a respectable question to ask, and the only plausible answer is, why not? Why in the world would you ever expect there to be nothing rather than something? It's not the kind of question to which we are ever going to get an answer that says, oh, it's because of this that there is something rather than nothing.
So ultimately there has to be a brute fact.
Absolutely. I think that brute facts are things we need to accept. The existence of the universe is probably one of them.
So the existence of the universe based on the laws of physics. And so the brute fact are the laws of physics, not the existence of the universe. The existence of the universe, in a sense, is a derivation of the laws of physics. I
think that when you talk about the laws of physics existing, that's a different thing than the universe existing. Right. So I'm not sure how to distinguish which is sort of prior or anything like that. I can't imagine the laws of physics existing without a universe existing, but the universe that we have obeys the laws of physics. So I think they come as a package. The universe and the laws of physics
That's an interesting point, because that's different than saying the laws of physics are the brute fact and that in the course of time, given enough time, it would throw up a universe.
Yeah,
that's a different position.
I would say it in a different way.
Your claim is that the universal laws of physics are cotemporary?
I would say that there is a quantum state that exists and it obeys the laws of physics.
And the quantum state is the universe?
Yes.
And so would there have ever been, I use the word time.
Right. You know that you're going down the wrong path.
Right. But could there have ever been a disaggregation between the existence of the universe, however you're defining it, and the laws of physics? Could that have ever been?
In my way of thinking, no. There's a quantum state that evolves through time according to the laws of physics, and that's all there ever was. And again, I'm happy to be wrong if we come to a better understanding. That's the best picture I can come up with right now.
Well, it does seem to be more coherent, because if you have the laws of physics by itself, and that throws up a universe, you have to, and you assume that the laws of physics, if it was a brute force, was there forever. Why did it do it now? Or
that's
why?
Right. Yes.
All those kinds of questions.
Yeah, and several very specific cosmological models have exactly that problem. They have a universe that sat there doing nothing for infinity years and then started expanding. And I don't think that's a very viable way of thinking.
Right. Now, some cosmologists say that the theory of inflation, which began our understanding of the current universe at least, requires there to be a beginning.
Yeah, they're wrong. I think that, for one thing, there are theorems about what space-time can do. And you take space-time into the past, and number one, you make some assumptions. And number two, under those assumptions, you say that the classical space-time comes to a singularity. But those assumptions might be wrong. That's always a possibility. And classical space-time is not the fundamental answer. We know the world is not classical. We know there is quantum mechanics. No one has a quantum theory of gravity for which there's a theorem that says the universe had to begin. In fact, it is trivial to prove the opposite theorem. If you have a time-dependent quantum state, it is obviously extendable infinitely far into the past.
So your position, to be clear, is that there's a quantum mechanical state that is the universe and the laws of physics as a singular package.
That's right.
And so does that mean that, from our perspective at least, that the universe is infinite in both directions?
That's right.
Past as well as future.
Yes.
And that at least has coherence, whether it's right or not.
That's right, yeah, exactly.
Sure.
So in my favorite cosmological model, which again is always subject to updating when new ideas or data come in, the universe doesn't have a beginning. It does not come into existence at a moment in time. It always existed. It looks different from moment to moment. And we are only observing a tiny part of it, so we don't even know what the whole thing looks like. But there's no need for an explanation to cause a beginning, something coming to existence out of nothing.
So if I'm with you on your path, I have one final question for that. And that is your quantum mechanical state with the universe and the laws of physics coexisting as a package. Is that necessary?
I don't think there are any necessary things other than sort of tautological, logical, or mathematical statements.
So it is, in essence, a pure brute fact that it's a contingent fact about the world, a brute fact that might not have been the case, but it is the case. So you would say that it could have been the case that there were absolutely nothing, but that's not the case.
I think, yeah, there's many possible worlds. Ours is one of them. There are others that are very different. There's nothing necessary about any one of them.
Wait, but different point. Is there a necessary that there be one other than nothing?
I see no reason for there to be anything necessary about the existence of a universe at all.
So therefore, there could have been nothing, in which there were no quantum mechanical states, no laws of physics, no universe, no nothing. There could have been that.
I'm perfectly willing to contemplate that nothingness, the absence of any universe or laws of physics, is absolutely a possibility that might have been in some space of possibilities. I also don't care at all. I know there are other physical universes that I think are very real, and I might be wrong about the nothingness. What I care much more about is the actual universe in which we live.
All right, that's it.
He's very eloquent in a good way.
Yeah, and consistent and strong, confident with his position. And again, so when you hear it, it sounds compelling. Carroll, what he does is he carefully sort of distinguishes between two kinds of. So when we say the universe, why is there something rather than nothing? He just wants to distinguish between two ways that you can interpret it. One, right, he says that if nothing is an empty space or quantum vacuum, then physics has a good idea, essentially, how we can more or less get from this kind of nothing to the universe we see before us, right? Here's where we would use the word nothingness. That's one way that you can interpret.
Yeah.
The other way is that if nothing is the absence of law of space and laws of nature, then this is something beyond Sean Carroll, essentially is what he's saying. So basically, right now, he just accepts, he uses that word, accepts the existence of the universe and the laws of nature. They cannot be prior to the physical universe. So the laws of nature and the physical universe are complementary, right? Things. Harken back to the last episode. You can't understand one without the other.
That's right.
Carroll doesn't see the need for there to be a beginning, nor for any part of the universe to have turned out one way or another. But in light of how finely tuned the universe is, as we've noted in the past, we know that the fact that a consciousness has been able to come to be and to essentially believe in the contingency of everything, as Carroll does, it required the constants of nature to be almost exactly as they are. He can believe in a contingent universe, and yet evidence, very real scientific evidence, seems to suggest that there might be something special about the configuration of the constants of nature having landed as they are. And Carroll needing, the necessity is, or the necessary condition is that Carroll, the Carroll that we just witnessed on this clip, had to reside in the same universe that we're residing in, watching. For us to be sort of consistent, right? We needed to be in the same universe under the same laws of physics and constants of nature. So there's something necessary about that matters, right? Because if he was alone in some other far off universe, right, who would he be speaking to? What would he really have that feeling of purpose, or would there be meaning to his work if there weren't others around to sort of say, you know what? Yeah, I see what you're talking about.
That's right.
So there's, I guess, a little bit of a critique. He just accepts something rather than nothing. But I guess what we want, maybe from Carroll, if we were to have the opportunity to sort of speak to him, is not just to accept it, right? He accepts that the universe is. But what we want to do is for him to take some time and reflect upon that and ask himself if the idea that there is something, again, the word beyond the universe, what does that mean to him? And how do you define beyond? Is it as we define it, the universe that we know is fully governed by the laws of nature, and so a beyond would be beyond science? Or is there some other definition, some other way that he could sort of explain, right, and share maybe his philosophy behind that? And does he place limits on science can do? That's what I would ask him. What did you?
I mean, I liked him in a certain sense. He's presenting a different sort of relationship to the universe than Krauss does, or Neil deGrasse Tyson does, and a variety of Michio Kaku does. He kind of like he's saying, well, the world is, and that's so interesting to me. He doesn't go beyond that in a kind of an assertion.
No, yeah, just wants to let it go. That's it.
Yeah, he doesn't seem to be interested in that assertion of there is nothing else kind of thing. There's nothing beyond, and so forth. So yeah, I think that in that he represents a pretty interesting response. The other thing that I like about this kind of interview, now we've used that interviewer, a few times now.
Yes.
I remember his name, and he does some really interesting discussions.
Well, he gets some really good popularizers on his show.
Yeah, he's talked with everybody.
Yeah.
So what's interesting for Carroll, in looking at people like Carroll, is that it's not a simple notion. So we can have notions about nothing and nothingness. And of course, as you have repeatedly said, it's a great phraseology. You can think around nothing, but you can't think about nothing. So even thinking around nothing is difficult. And so once you sort of know that we're approaching it as a thinking around, even then it's a little bit hard to maintain, because while we constantly say that nothing lies off the cliff edge of all the continuums of the world, off the cliff edge of materiality, off the cliff edge of thinking, off the cliff edge of selfhood, and so forth. Of late, you've been saying that's the beyond. Mm-hmm. Off the cliff edge is the beyond. At the same notion within your conceptual, remember, we got to juggle, right? You have to juggle. You have to keep a kind of a system going here.
That's the pattern.
At the same time, nothing is permeates the world.
It's not just beyond, it's right here with us.
So the notion of beyond is not separate. It's beyond certain criteria of understanding, certain concepts of what reality is, but still present in the sense that we call it the permeating. And it's we've gone further to say, because we've looked at various notions of Taoism and other things like that, that a nothing provides an isometric balance to the manifest, and it's only in that isometric balance that the world works at all. So it's not a simple thing. In a certain sense, Krauss takes a kind of belligerent, demanding position relative to nothing. Carroll takes a more humble or accepting, but also playful and good-natured attitude toward nothing. Neither of them are really holding the nihilological concept in completion, but they're showing various ways of trying to do it. And that's why I thought Carroll was interesting, because he's so different than Krauss, and actually very interesting. So, yeah, that's a good clip.
Well, this thinking beyond, I'm glad that you brought that up. I had another little chaotic here that I thought of a while ago, but how he said it's not easy, right, to sometimes think beyond, right, because I think that it's that we know that it lies beyond, but what we have to do is kind of like the talk around nothing, right? It's like you have to be aware of the perimeter. You have to have walked the perimeter of nothing in a way to be able to talk around nothing, essentially. Right. So that might be the difficult aspect of it, right? That you had to have taken the time to sort of see it from all sides, right? But then you brought up just now about like how it's not just beyond, the nothing is not just beyond our world, it's actually within it, right here on Earth. Right. And so here's a visual that could help you, I guess the listener, right? It's the Menger sponge. So do you see that this cube has been, what we've done is we've taken a cube, right? And we've taken out a cube from the middle of each side. And then we take a cube from the middle within each of these quadrants. We take a cube. Another cube. We just I guess repeat this taking away of cubes within the larger cube, and we do this ad infinitum, right? We keep taking away cubes upon cubes. Now, what are we left with at the end? Are we left with quote unquote empty space? No, we're not left with empty space. Mathematically, we're left with this kind of a structure. A structure with, very interestingly enough, has infinite surface area. Infinite surface area, but zero volume.
Surface area because of all the sponging, the puddling.
Essentially, yeah. So remember that a surface area cube is length times width times height. Okay. So when it's solid, if we take out just one cubic area, forget about this whole tessellation pattern, right? And we just take out one cube. Now we've taken away volume. We take out a cube from the big cube, but we've added surface area because what was a flat top, now we've exposed as 1, 2, 3, 4, and then the base is 5. We've exposed 5 sides. Well, where there was one solid side, now there are 4 sides. So you see that we've added to the surface area.
Right.
Every time we take out a cube, we're adding sides to the cube, right? And so if we do it infinitely, if we take out infinite number of cubes, we're adding infinite number of sides.
Okay.
So infinite surface area. And yet, because every time we're taking out, we're left with zero volume at infinity. And so what we're left with is this sponge that maybe the way of visualizing sort of the way our world is and how fluid nothing, right? And now nothing is the beyond the cube. What was simply beyond the cube, the universe here is represented by the solid cube. Initially, that's how we conceptualize it, that there's a separation, like a physical barrier between our universe, right, and the beyond. Now what we can do is we can visualize it like this, more like a Menger sponge, and see that nothing sort of flows in and out of our universe. There is something distinct about our universe, but nothing is not just a beyond. It's actually all around us.
That's amazing. What was the original purpose of the Menger cube, you know?
I think it's just a mathematical construct, right? It's just a cool idea, as math always is, right? The mathematicians aren't interested in physical, seeing this in nature, right? There are no processes that can be done to infinity, right? These are all mathematical, like, sort of ideas. You know, but the idea is a cool idea, right? That there could be something that has infinite surface area and zero volume.
Zero volume. And the more you take away, the more surface you
the more surface that there is, yes.
Yeah, that's consistent with a lot of these kind of rarefying principles.
That's right. That's right. Rarefying, remember, is rarefying in density, right? Because the more we look, it seems like that there's more stuff in the universe, right? But the thing is that the universe is larger than we ever thought before.
Right.
So that's how it's becoming rarefied. There's a lot more space in between stuff, but there's more stuff at the same time.
Yeah, this is great. I didn't know about this.
So you could actually almost, if we were to take this and again apply it like chaotic here, is that you can almost think of the vertices or the edges of this Menger sponge, I guess, as stuff. We're taking away matter, or we're taking away, or the universe is getting larger, right? In surface area, it's becoming more rarefied because there's less physical stuff there. As we do this, you can think each side that appears is like a new physical entity that appears in our universe, right? And yet, the more that this happens, the less dense the universe becomes.
Right.
Okay? So there's like this multiplicity of things. So science will never die out. There'll always be nice, interesting things to sort of study and look at. But as we are doing it, as the more we observe, right, the less solid, right, the universe becomes, right? The more expansive it is, and in that sense, right, the universe is becoming rarefied, right?
That's right.
Less dense.
No, that's a great image. I didn't know anything about that, so I learned something today.
Not just the beyond. You know, the nothing is here beside us too. We don't have to look to the stars to find it. We don't have to be cosmologists or astrophysicists. We can find, nothing. Just being with our children, or or making widgets.
That you call it a beyond is really helpful in certain conversations. You need to do it in certain conversations, and you need to, after using it, then you need to pull it under. You need to pull it back all the time.
Pull it back a little bit.
But the beyond and the permeation are both useful. And again, that's just a different form of thinking around.
That's all we got for this week, I think.
Okay. See you next week.
Next week.
Okay, see ya.
Bye-bye. Entering the Universe has been brought to you by the Society of Namecoin.
Until next time. No.